Hello class, welcome back to my YouTube channel. Today we are starting our design and analysis of experiment class 2. So in our previous class we learned something on about three designs that we have in design and analysis of our experiments course. Then we discussed something on completely randomized block design, Latin square designs. And then when we were treating the Latin square designs, we saw that we find out the Latin what letters in what individual treatment that we have in our designs. So we are going to pick that idea from the Latin square to come and treat a course a topic called Greco Latin square what designs. So for Greco Latin square designs, you will see that there will be a Greek letter and then a Latin letter combined together, and then they will be appearing exactly once in what each individual treatment that we have in our experiment. But in our experiment, there will be no case that the Greek letter and the Latin letter will appear twice or thrice in our experiment. Always it should be exactly one. It should appear exactly once, right? But when it appears exactly two, it means that that design is not what a Greco-Latin square design. So always, as I have told you, that is how it will appear. So, for example, if you have 4 by 4 Greco-Latin square designs, this is how it will be. As I was explaining, you see that we have a Latin letter here and then a Greek one letter here. So always the Latin letter and the Greek letter is written together, right? And you can see that the A and the alpha just appear once in what row one, and also just appear once in what column one. So that is what is going to happen in all one the treatment. So as I told you, if you see any letter, a Greek letter or a Latin letter appearing twice in this design, then this design is not what a Greco-Latin square what designs. So for Greco-Latin square designs, these designs allows us to investigate what some factors that we have in these designs, and then we have about 4 factors in the Greco-Latin square what designs. We have what rows, right? We have columns, we have the Latin letters, and then what Greek what letters. That's the 4 main factors that we have in these designs that it allows us to investigate. And through the investigation of what these factors in the Greco-Latin square designs, we have to understand the statistical method for the Greco-Latin square design, so that we really appreciate how we are going to investigate what these 4 factors that we have in the design. So as you can see on the screen, the statistical method is shown on the screen as yijkl is equal to what you can see here, right? So the y subscript ijkl is just the observation in the rows and what the columns. So when you come at the top here, the example that I just shown you, the 4 by 4 Greco-Latin square design. So the y subscript ijkl is just what the observation, as you can see here in row 1, column 1, right? Row 2, column 2, row 3, column 3, row 4, column 4, right? So the y subscript ijkl is just all the observation that we have in what our design. And then the mu that you see here is what just the ground one mean, and the theta I is just the effect of the I row that we have in what our experiment, and the tie j, right, is just the effect of what the Latin what treatment. And then the WK is what the effect of what the Greek what treatment, and then tie what L is what the effect of the I what column. The last one is what the E subscript IJKM is what just the error term that we have in what our experiment. And then before we can really appreciate or have any good use of this design, we have to know what the analysis of variance for the Greco-Latin square what designs. So for the analysis of variance, you see, we're just discussing that we have the Greco-Latin square design just give us or allows us to investigate about some factors, and we just learned that factors are about 4: the rows, the columns, the Latin letters, and the Greek one letters. So for the analysis of what variance for the Greco-Latin square designs, we are going to use these factors to do what our analysis of what variance for the design. So the first one that we are going to concentrate on is what? The sum of square what? Row. So we are just going to go through the formulas for the sum of square row, the sum of square Latin, the sum of square for the Greek letters, and the sum of square for what? The columns. Then you will also go through the sum of square total and what? The error term. So once we are done with that, then we use that to form an analysis of variance one table, and then you know how you do things there and then make one conclusion about that. So we have what? The sum of square what? Row. So the sum of square row is usually written as SS subscript what? R, right? So as once you see this one, it's just sum of square row. So this one is just equal to 1 over P summation of ij moving from 1 to 1 P times yi all squared minus y dot 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 divided by n squared, right? So let me just give an explanation to the symbols that you see here, the yi dot dot and then y dot I dot dot and the rest. Let me give explanation to that so that as you see this one, it will not be something ambiguous to you, right? So let's come down here and list the explanation down there. So when you see the yi dot dot dot, it's just telling you that it's just the summation of what the individual rows that we have. So let's visit our 4x4 Latin, Greco Latin square design, and then let me teach you how it is. So if you want, if you want the y I dot dot dot, right? So for the one, when you come to the row 1, you are just going to sum all the distance here, the individual numbers that we have in here, right? For the Latin letters that you see there. Yeah, so you're going to just sum them right here, and then write the summation here, right? And when it comes to the 2 we are going to just sum them, right? So the y subscript I dot 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 is just the summation of what? The individual what? Summation of what? The individual rows. And then y dot j dot dot is what? The summation of what? The Latin letters for the individual the summation of the Latin letters for the individual letters that we have in the column, right? So when you come here, we are just going to sum the Latin letters, right? So when you take A, you just write the value for A at column 1, write the value for A at column 2, right? Write the value for A at column 3, write the value for A at what? Column 4, right? So you just write all the value and then sum, right? So when you take B, I'm going to do the same thing. I'm going to take the value for B at column 1, take the value for B at column 2, take the value for B at column 3, take the value of B at column 4, right? And when you come to the C2, you are going to do same, right? So whenever you see y subscript I dot j dot dot in our formulas, we are just telling you the summation of the Latin letters for the individual treatment that we have. So sorry, here is not letters, it's treatment. So let me let me do some small corrections. So this is what? Treatment, individual what? Individual treatment, right? Individual treatment, right? So let's go to the y dot dot k dot, right? So the y dot dot k dot here is just the summation of what? The Greek letter, right? For the individual what? Treatment, right? So the same thing, individual what? Treatment, right? And then the y dot 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 l is equal to what? The summation of what? The individual what? Columns, as you can see. So here too, when you come to this design, we are just going to take for the Greek also letters, you are going to take alpha for each treatment and then add. So you take alpha for treatment 1 and then add, or for column 1 and add alpha for column 2 and add alpha for column 3 and add alpha for column 4 and then add them together. And then you take beta 2 for column 1, column 2, column 3 and column 4 and then add them, right? So that is how you do for the Greek letters too. And then for the column 2, you are just going to add the individual columns that we have for that. So you really appreciating these symbols will also help you to understand the formulas for the design, right? So here we are just going to just 1 over p. So for the p is what the design, right? The matrix for the design. So here we are having 4 by 4 design, right? So the p will be what? The 4, right? Since you have 4 by 4 design, if you have 5 by 5 design, the p will be what? 5, right? So here we are having 1 over what? P summation of what? The individual what? Rows all squared minus y subscript dot 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 dot. So the y subscript dot 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 is what? You are going to take the individual observation under each treatment, right? So when you come here, you take we are just going to add all the individual observation that we have here and then just square it, right? We are going to add alpha times a plus b times beta plus that. So we're going to take all the individual observation, add them together, and then after you are done, then you square them, right? So that is that for the row. And then p minus 1, as you can see here, is what? For the degrees of what? Freedom, right? The degrees of freedom is what? P minus 1. And then the sum of square for the Latin, right, is also 1 over p summation of the individual Latin letters added together. So once you add for the first Latin letter, let's say A, once you add it, then after that you square it. When you take B, you add it together, after that then you square it. So to be summation of what? The individual Latin letters that we have in the treatment minus y, the same thing, right, as we learned at here, the same thing that in fact you are going to repeat this one through all the formulas that we have, right? We're going to repeat it. It will be the same thing. So what you have to change is when you come to what the sum of square for the Latin, we just concentrate on the Latin letters. When you come for the sum of square for the Greek, you just concentrate on the Greek size. And when you come for the sum of square for the column, you just concentrate on what? The summation of the column side, right? So this is how things moves for the sum of square row, sum of square for the Latin, sum of square for the Greek, and sum of square for what? The row. And then we also touch on sum of square total and what? The sum of square what? Error. So the sum of square total, since we are having about 4 factors, right, that we were trying to investigate, the summation too will be, we will sum all the summation over all the 4 factors. For the summation for I, summation for J, summation on the row, summation on what? The Latin, summation on the Greek, and the summation for what? The column, right? So we are going to sum all the observation, right, individual observation under this one, and just as you assign, then you square it, right, minus the same thing as we just discussed, that you're going to just repeat throughout, right? So for the sum of square total too, we have p squared minus 1 to be what? Our degrees of what? Freedom, right? And then for the sum of square error is just in fact sum of square total, right? Yeah, let me write this thing here for us to really appreciate. So for sum of square total, we are saying that sum of square total is equal to sum of square row plus sum of square Latin plus sum of square Greek plus sum of square Greek plus sum of square column plus sum of square error, right? So if you want to find this error, right, we are just going to make the error subject. Sum of square error is equal to sum of square total minus sum of square row minus sum of square Latin minus sum of square Greek minus sum of square what? Column, right? So once you make the subject, you are going to get this one. So once we have the total and the rest of this one, it's easy for us to find what? The sum of square what? Error. So once we have this formulas and then degrees of freedom, let's put it in analysis of what? Variance what? Let's put it in analysis of variance what? Table, for us to really appreciate what we are trying to do here. So here our main focus is going to be on what? Our main focus is going to be on the Greek and what? The Latin what? Letters, right? So here we have our source of variation for the Latin, Greek, row, column, error, and what? Total, right? So when we come at the source of sum of our squares, I'm going to calculate the individual sum of squares for the Latin, for the Greek, for the rows, columns, error, and what total, as we just discussed at the top there. And then as degrees of freedom, we are going to assign the degrees of freedom for the sum of square Latin, for the Greek rows, columns, the error, and what the sum of square for the total, degrees of freedom for this individual distance. So if you want the MSE, that's the mean square, right? You are just going to divide the sum of square for the Latin divided by what the degrees of freedom for the Latin, as you can see here, for us to get our mean, right? So that we get our mean square will help us to find our f and then make our conclusions, right? So once we have this thing here, it's easy for us to find our f. So if we want to get our f value, f critical value for the Latin, it's just the ms, the sum of square, sorry, the mean square for the Latin divided by what, the mean sum of what, error, right? That way, so once you divide this one by the error, we are going to get our f. And if you want for the Greek too, I'm just going to divide the mean square for the Greek by what, the error term, right? Once you divide, you get the f critical for the Greek. So basically, this is how things work for the Greco Latin square design. So these are the formulas. So in our next video, we are going to solve an example for us to really appreciate whatever we were discussing in this section. Thank you. Have a nice day.